Guy, it's your turn to feed the fish today. Oh. It's your turn to feed the fish today. Oh.
Relax, I'll do it now.
From your bed.
They play.
Just they play. They play.
Hi, my name is Khalifa. I think there are a few things cooler than being able to control something with just a gesture. You could be on your couch and control something in an entirely different city. Or you could turn on your car with just the push of a button. And you can even turn off the lights in your room with just a clap. Ah, NEPA. In today's video, we're going to be building an automated fish farm. It was actually a friend of mine, Kennedy's idea. He had just started a fish farm, and both of us being students of mechatronics engineering were both obsessed with automation. So he suggested that we automated some of the processes and integrated some form of wireless control. Apart from it being just cool, there are so many benefits of automation. I think the increased efficiency and productivity goes without saying. Automation streamlines crucial tasks like feeding and water regulation. This efficiency ensures that the fish receive consistent care, leading to healthier and faster growth. With automation, there's less need for physical presence at the farm, reducing labor costs. A single farmer can manage a larger operation with less effort. You also have access to real-time data. Access to sensor data such as water temperature, pH, salinity, turbidity, and oxygen levels provides invaluable insights into the farm's conditions. Farmers can make data-driven decisions to optimize the environment for the fish. And one of the biggest concerns for farmers, security. Having a camera system provides security for the farm. Farmers can monitor the farm remotely and receive notifications if there is unauthorized access. This enhances the safety of both the fish and the farm infrastructure. And that leads us to event notifications. Instant notifications for events like tank overflow, exceeding temperature, non-conducive water conditions, or equipment malfunctions allow for timely intervention, reducing the risk of fish loss and property damage. In this video, we'll cover the automation of feeding the fish and water regulation. We'll also set up a mobile app where the farmer can monitor the temperature and water level of each tank. The mobile app will also be responsible for sending notifications to the farmer. To achieve all of this, we needed some extra hands, so we brought our friend Mela on board. Shared our roles and we were ready to get started. Using SolidWorks, I got started right away on the design of the feeder bin. The feeder bin was designed to contain and dispense fish feed and has a capacity of up to 14 liters. The bin is made up of 7 parts excluding the stepper motor, the 4 plates that make up the outer structure, a case for the auger itself or screw feeder if you like, and a case for the stepper motor to attach it to the bin. Without wasting any time, we got started on the build. I was still really busy working out the electronics. So I forwarded the designs to Kennedy and he got started right away fabricating the metal bin over there in Lagos. We went over the design so many times because of how complicated some parts were, but he ended up doing a very good job in the end. Because of the complex design of the screw feeder and the stepper motor cases, those two would need to be 3D printed. So as soon as I was done with their design, I converted the solid part files to STL and headed straight to the 3D printers. And I think they came out pretty well if you ask me. And it was time to start building. I started by taking off the old test print on the stepper motor and putting on the new one. Some of the edges needed to be sanded a bit because of how rough they were. At first I was afraid it wasn't going to fit, but after applying a little force, it finally made that satisfying click sound. Now, all we need to do is put in some screws to make sure the motor remains secure. And now we'll do the second one. Next, we'll attach the screw feeders. Looking good! Now moving on to my favorite part, the electronics. We'll be using 2 NEMA 17HS4401 stepper motors, one for each fish pond. I chose this stepper motor because it has a holding torque of up to 40 Newton centimeters, which is perfect for our application here. And to drive those motors, we'll be using an A4988N stepper motor driver, together with its heatsink of course, because these guys get hot very quickly. For the brains of the operation, we'll be using an ESP32 microcontroller, HCSR04 ultrasonic sensors for measuring water level, these really cool 12-volt solenoid valves, a waterproof temperature sensor, a 4-channel relay module, a couple of capacitors, and a lot of voltage regulators. Before connecting anything, I needed to do a lot of calculations first, just so that I wouldn't blow anything up. But knowing myself, even that wouldn't be enough to stop me. After making all of the necessary calculations, I started to connect everything temporarily onto a breadboard first. Then I used a multimeter to make sure all of my connections were correct. Test. And when I was done with all the connections, it was time to finally write down some code. After uploading the code, it was time for the moment of truth. The screw feeder kept rotating off-center, so I had to melt it a bit and kind of bend it back into shape. It didn't work perfectly, but it was much better than it was before. Everything was working perfectly at this point, but I just had to test it by myself, just to be sure. I made a makeshift casing for the screw feeder out of cardboard and filled it up with chewing gum to serve as the fish feed. And the screw feeder was feeding, but I just needed to be sure. Now I could be sure that everything was working. Next, I drew a little schematic of how I wanted the circuit board to look like. Then I headed straight to Altium Designer to replicate my design. Done. This is a fiberglass perf board. I prefer using perf boards to Vero boards for my projects because the dots are tinned individually unlike Vero boards, allowing you to make more complex connections on the surface. Now, to make our circuit board, all you need to do is leave the board overnight and voila, here's our circuit. I'm joking. To make what we have here took hours of soldering. And this is what we have at the back. I like to color code all of my tracks so that I can differentiate ground from positive voltage and positive voltage from signal lines. Let's have a brief overview of our circuit board. At the center we have the microcontroller, a 5-watt choke resistor for limiting the voltage on our valves. We have a screw terminal for the power switch, a voltage regulator, female JST connectors for interfacing with our valves, a power LED indicator, a 12 volts input jack, auxiliary pins for 5 volts ground and signal, a rack for all of our sensors that will be connecting, and to the right we have our stepper motor drivers, with some capacitors connected according to the driver datasheet. Now that we had all of the major parts ready, it was time for me to head over to Lagos and meet up with Kenny to set up the farm. We headed to a nearby market to get some equipment we needed to set up the farm, and then we got right to work. It was my first time seeing the babies in person. Aren't they pretty? But there was one more part that we hadn't made yet, and that was the auger case. So we consulted the neighborhood welder. He's such an easygoing elderly man that everyone calls him Jeje or Baba Gentle, and he lent us his help in making all of the metal parts. Here's a little build montage for you. After successfully mounting the feeder bin, we wanted to go ahead and connect all of the sensors. But it was already really dark and pretty late, so we left that for the following day. The first thing we did the next day was to tap a power outlet from inside the house, so that we could power the system and also have a light bulb allowing us to work late. And we had a lot of fun while doing that. When we got back to work, we attached the ultrasonic sensors to these metal bars that would sit on top of the tank.
Then the same thing for the other side. Next, I measured the dimensions of the tank so that the ultrasonic sensor would be able to tell the water level. The sensor is able to do this by measuring the distance between the water surface and the metal bar. Then it subtracts this distance from the height of the tank and calculates the total volume. And then I got to work on the temperature sensor. According to the sensor's datasheet, it requires a 4.7K resistor between the 5V and signal pins. I didn't have exactly 4.7K, so I connected a 10K and 8.2K resistor, which would approximately give 4.7K ohms in parallel. Then I just needed to insulate the solder joints. Next, I connected the valves to electricity and had them insulated. For the third night in a row, we had worked past midnight, and at this point we were wondering who sent us to do this work. We had to take our time ensuring that all of the wires were insulated, especially the ones connected to the tank. Now that everything was in place, we could finally hook it all up to the circuit board. I did some last minute fine tuning of the code just to make sure that everything would work fine. I also did some troubleshooting of the circuit to make sure everything was connected as it should be. We set up the mobile app that allows you to control the flow of water to each tank, displays the temperature and water level of each tank, and also allows you to feed the fish exact amounts of feed. The app can even send important notifications to the farmer, such as when the tank is overflowing with water or when the fish haven't been fed in a while. The farmer can also set automations from the app, such as when to feed the fish or when to change their water. We tested the app on different devices and everything was working perfectly, with little to no input lag. Next, we tested the feeder, and that also seemed to be working fine. All we needed to do now was calibrate the feeder to dispense precise amounts of fish feed. Now that we're done, here's a little before and after. Everything turned out to be way more work than we had bargained for, but in the end, I'm sure we made our fish and their farmers very happy.